For day 2 of 9.6, what we just did is reviewed what we did on day 1, which was solving quadratic equations using our newest method, which is by the quadratic formula. Just a couple things to keep in mind. First of all, the equation must be in what we call standard form before you start using the formula. What that means is you have to have your x squared term first, followed by bx, followed by the constant term or the c term, and it must all be equal to 0. So there might be some rearranging you need to do first. Meaning, if you have, say, maybe 2x squared is equal to negative 3x plus 7, we need to get that right-hand side equal to 0, which means we're going to move the 3x over by adding it to both sides. We'd get 2x squared plus 3x is equal to 7, and then we need to move the 7 over by subtracting it from both sides, leaving us with 2x squared plus 3x minus 7 equals 0. It's after that that you identify your A, your B, and your C. So if it's not equal to 0, you need to take the opposite of everything that's on the right-hand side to move it over to the left-hand side. Once it's in standard form, we just use the quadratic formula as given yesterday, and we sung it to Pop Goes the Weasel, and it should be pretty easy to memorize. So I'm going to go through 2 examples, and that ought to be enough. So the first one is already in standard form, ax squared, where a is 1, plus bx, where b is negative 3, plus c, where c is negative 10. So I'm just going to identify my a, identify my b, watch the signs, make sure you bring that negative 3 over, and identify my c as a negative 10. Then I'm going to use my formula, which says that the x values are equal to negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now we do what I call plug and chug. You just go take each of these and plug them into the formula. Be careful of your signs. So I'd have x is equal to the opposite of b, which would be a positive 3, plus or minus the square root. And then I suggest that you square this in your head first, because what happens is, if you don't do that in your head and say negative 3 times negative 3 is 9, what problem occurs is that sometimes kids will go put that negative 3 into the formula and then square it on their calculator. And if you forget to put it in parentheses, it's going to give you a negative 9 instead of a positive 9. So just a thing to note, this lead number under the root will always be positive, because no matter what you square, be it 3 or be it negative 3, when you square each of these, you get a 9. So make sure you're always leading with a positive number under that root. Then the formula says we subtract 4 times a times c. A is a 1 going into the first set of parentheses. C is a negative 10 going into the second set of parentheses. It's all over twice a, or 2 times 1, which is 2. Next step in the process was to clean up under this root. This one can be done in your head, or if your arithmetic is a little shaky, you might want to do that on your calculator. But you'll end up getting 9, and then these 2 negatives will make a positive, so it's 9 plus 40, or there's a 49 under that root. Make sure you write that as 3 plus or minus the square root of 49. I have not rooted it yet, so make sure that root stays in there. We know the square root of 49 is exactly 7. If that was, say, the square root of 48, which we don't know exactly, you are usually asked to round it to the hundredth, so you'd have to go to your calculator. But this one is a perfect square, so it's just 3 plus or minus 7 all over 2. At this stage in the formula, we branch off, and we're going to get 2 answers. One, when we add 7, and another one when we subtract 7. So on the top, we're going to do 3 plus 7, which is 10, divided by 2 is 5. So one of my solutions to this quadratic equation is 5. Keep in mind you could always test it. You could go plug a 5 in right here and square it, subtract 3 times 5, subtract 10, and you will get a 0 out. My other solution comes from doing the subtraction. I do 3 minus 7, which is a negative 4, over 2, which is negative 2. So these are my two solutions. Let's talk a little bit more in depth about what that means. First of all, had I graphed it, it's a parabola. It opens up. How do I know it opens up? I know that because it's leading in a positive x squared. I could find the vertex using my methods from section 9.2. If I went to my graphing calculator, what that means is these represent the x-intercepts of my graph. I also know that my graph opens up because of this positive x squared. I actually also know its y-intercept is at 0, negative 10. And so really what that would look like, and it hits what at 5 there, something like this, where it's hitting at negative 2 and 5. Also, because this original quadratic equation, my markers aren't working too well here, is factorable, I really didn't need the quadratic formula for this one. Keep in mind, I could have just factored it into x minus 5 times x plus 2, because this unfoils or factors into that. And then we could say, well, then x has to equal 5 or negative 2. Notice this green method of factoring is much slicker for this problem. But also keep in mind that the reason we had to teach you the quadratic formula is because the minute this ends in an 11, it doesn't factor and that method falls apart and you have to use the quadratic formula. So because in 9.6 we're practicing the quadratic formula, I want you to use that exclusively, but I also want you to realize that if they're factorable, that's actually a preferable method because it's faster. Alright, so this will be the last one we're going to do. This is not in standard form. I need to have it equal to 0. So I need to subtract 2x, do the opposite of it, to get it equal to 0. On the left, to write it in standard form, I need to have ax squared, then my bx, then my c. Make sure they get in the right order so that you're not plucking those coefficients off incorrectly. Now it's equal to 0. Let's repeat the process we just did. For this one, a is equal to 1, b is equal to negative 2, c is equal to negative 8. Those get plugged into my formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The formula never changes, the process never changes. The only thing that changes really are the answers. So it's going to be an identical process to what we just did above. We got to plug these in. The opposite of b, or negative 2, is a positive 2. Plus or minus the square root. We're going to square that before it goes in to avoid a sign error. Negative 2 times negative 2 is positive 4. Remember, you should always lead with a positive. And it'll be b squared minus 4 times a times c. Use parentheses to keep it nice and neat and clean. A is a 1, c is a negative 8. And we're all over 2 times a. And a was a 1 again, so it's all over 2. Next thing I do is I clean up the ugly part of this formula, which is under the root. I do it in my head or I do it on my calculator. But when I do, I get a positive 36. Keep in mind that if at any time you get a negative under that root, we get to stop and say there's no solutions because we can't root negatives. But this one's a positive 36. Which is a nice perfect square. Don't forget it's living under that root, so we're going to keep it there. And now I simply take the square root of 36, which is exact. Again, if that was square root of 37, I just go to my calculator and I'd round to the nearest hundredth, and I'd continue the process in identical fashion. I would just have some decimals coming along for the ride also. So I'm at 2 plus or minus 6 all over 2. And at this point, this is where I branch off and get my two answers. I add on one branch and I subtract on the other. So I do 2 plus 6 on this path, giving me an 8 over 2, which is 4. And then I do 2 minus 6 on this path, giving me a negative 4 over 2, which is a negative 2. And these are my two solutions. The assignment for 9-6B was the puzzle worksheet, numbers 1 through 12, done on a separate sheet of paper, showing all work. So your work is going to be a lot because every problem is going to be this long, showing all work. And then also that worksheet has the answers over on the right-hand side. So I don't care if you solve the code, but I'd like you to make sure that you find all your answers over on the right. Also, there's one of these 12 that does have the answer of no solution. What I'm telling you is there is one of them where when you're in this process, you're going to go under this root and you're going to get a negative and you're just going to get to quit. But that should only happen to you one time in the 12.